In this video, I want us to take a quick look at the mass spectrometer. Now, there is one theory of Dalton that says that atoms of the same element will have the same mass and the same size. Now, that was believed to be true for a very long time, but then along the line, this theory was disproved by what is known as isotopy. So we have isotopy that disproved this theory. Okay, so with isotopy, we came to find out that we can have atoms of the same element with different masses because they will be having different number of neutrons. Okay, now how do we do that? That is where the mass spectrometer comes in. The mass spectrometer helps us to identify isotopes of various elements. So this setup here is a setup that illustrates how the mass spectrometer works. So how does it work? First, it has five chambers that we'll be looking at. The first one, the first one is a vaporization chamber. It has a vaporization chamber. Then it has the ionization chamber. It has the ionization chamber. Then it has an electric field. And then number four, it has it has what is known as magnetic field. Then number five, it has the detector. So vaporization chamber, ionization chamber, electric field, magnetic field, and then the detector. So let's look at how it works. Now this is set up which is like a tube. Now the first thing to do is to pump air out of this to create a vacuum. Okay, so we can say that this is a vacuum pump. So to vacuum pump. Okay, now once we remove anything that is not needed out of this tube, then we can now focus on our sample. So we can have a sample there, which may be a piece of solid or liquid. Then what happens is that this sample here gets heated by this filament. Okay, there's a filament there, this one. So we can label this heated filament. So this is very hot and so it causes this to vaporize. So when it vaporizes, what happens next is that we have the electron gun, which is used to shoot electrons. Okay, so this goes in shooting electrons. So what happens is that if this is in an atomic state, and then we have high-speed electrons that is being used to bombard it, what is going to happen is that it is going to knock off electron to make this positive ion. So it knocks off electron from the atom, making it to be positive because anytime we lose electron, we become positive. Okay, so that's what happens there. Now, once this loses an electron, so well, you may say that what happens to the mass? Won't it change the mass? No, the fact is that the mass of the electron is very small, such that it is negligible. So the atomize or the atoms loses an electron and still it has no effect on the mass. Okay, so it becomes positively charged. Now once it becomes positively charged, it gets accelerated by the electric field. So if you are looking at this electrode here, it is positively charged. So what is going to happen is that is going to repel this towards the negatively charged plates. So we would be expecting the ions to move in a straight path. We expect it to be moving in a straight path. Okay. Once this repel it towards the negatively charged plate, when it reaches here, it gets repelled again towards the magnetic field. So what we have here is a magnet. So it generates a field, so there's a magnet. So that's our magnet. So around here, we're going to have a magnetic field. Now, what happens to ions in magnetic field? They get deflected. Okay, they get deflected. Now, the deflection is going to base on the mass of the atom. If you are light, you can get deflected over a wide angle. You get deflected over a wide angle. But if you are heavy, the deflection is not going to be that much. Okay, the deflection is not going to be that much. Now, what happens to the deflected ions? They come here and hit the detector. Okay, so over here we have the detector. So this is the detector. Now, what's the function of the detector? Once we have the ions hitting the surface of the detector, it has an amplifier that is being connected to the computer. So the computer begins to plot a graph based on how much of the ions that is hitting a particular spot on the detector. Okay, so this is a part of the ions that are being generated from the ionization chamber, which we are expecting to move in a straight line. But once it enters the magnetic field, it gets deflected depending on the mass to charge ratio. Now, the heavier it is, the more difficult it is to be deflected using the magnet. Okay. Now, the lighter it is, the more it gets deflected through a wider angle. So we would have been expecting that this will continue in a straight line. But because of the magnetic field, it will be reflected onto the detector. Okay, so this is spot A and this is spot B, all right, based on their masses. So assuming this is a chlorine atom, is what is going to happen in there. You have two spots, okay? You have two spots. So on your computer, you begin to see this graph showing you two peaks. That means that we have masses we have two masses, or we have two atoms hitting different spots on the detector based on how heavy they are. Now you find out that the heavier one, which is chlorine 37, got deflected to the spot B, okay, and the lighter one got deflected to the spot A. Now on the y-axis we have the relative abundance, or it's also known as intensity, okay. Now if you should label this would have been 75, okay, because the ratio is like 1 is to 3. So if this is 75, if this is like 75% of the total, then this is going to be like 25% of the total. Now, based on this information, we can calculate the average atomic mass of a particular element. So how do you do that? We do that by multiplying the mass with the abundance, okay? Mass times the abundance of, let's say, fractional abundance. So mass of the first isotope times its fractional abundance. And then we add it to the mass of the second isotope multiplied by its fractional abundance. Okay, so the mass for the first isotope 35, a mass of 35 times the fractional abundance, which is going to be 75 divided by 100. Okay, then we add this to the mass of the second isotope, which is 37 times 25 over 100. Now, when we work this out, we get the average atomic mass of chlorine atom. okay, the average atomic mass of chlorine atom, which is going to be 35.5. Okay, so this is how the mass spectrometer works, and it helps us to determine atoms, isotopes of atoms based on how heavy they are.